Hi guys, this is the last video for this test, so I wanted to make sure you got absolute value equations down because I think that's the last homework that is on for due Monday night. Alright, absolute value equations. Alright, so the first thing I want to talk to you about is what is the definition of absolute value. Okay? The definition of absolute value that y'all have probably always been told is that it always makes a number positive. But why does it make a number positive? Let's look at a number line. Alright, so let's start with 0. If I wanted to say, tell me what number has a distance of 2 units from 0, you would say we have 2. We go 2 units to the right, which is positive 2, but we also go 2 units to the left, where it is negative 2. Okay, so when you're talking about distance, distance is never negative. So when we're talking about a distance of 2 units, that's 2 units. And this is 2 units. So again, mathematicians are lazy and they want to come up with shortcuts for the way they write things. So absolute value is the way they do that. So what this statement says, the absolute value of x is equal to 2. It says, what number has a distance of 2 units from 0? Okay, and that would be the numbers 2, negative 2. Okay, so that kind of tells me how I'm going to set up any absolute value equation. Okay, so let's start off with an easy one. Let's just say that I have the absolute value of x is equal to 7. So I'm going to set up 2 equations. I'm going to say absolute value of x is equal to 7. Absolute value of x is equal to negative 7. So that our solution set is x is equal to negative 7, 7. Simple as that. So if I have an expression on the inside, and I'm going to do 2 because I want to explain the difference, okay? So we get the absolute value of x, 3x plus 1 is equal to 2. So I'm going to set up 2 equations. 3x plus 1 equals 2. And then 3x plus 1 equals negative 2. Now I can solve each one of those equations and get 2 answers. So that I have negative 1, subtract 1 from both sides. So I would have 3x is equal to 1. Then divide both sides by 3. So I'd have x equals 1/3. Now I'm going to subtract 1 from both sides. 3x is equal to negative 3. Divide both sides by 3. And I get x is equal to negative 1. So my solution set is x is equal to 1/3 and negative 1. Okay, the reason I want to do another example is I want to show you that what is inside the absolute value comes out. And what I mean by that is, what if I had the absolute value of 2x minus 3 is equal to 8? All right, I know that you've been told that the absolute value makes everything that comes out positive, but when it's in terms of an expression, the expression comes out just like it is in the absolute value. Okay, so what I'm going to set up here is 2x minus 3 is equal to 8, or 2x minus 3 equals negative 8. All right, I'm going to come over here and tell you what's wrong. Okay, what would be wrong to set up would be 2x plus 3 equals 8. 2x plus 3 equals negative 8. This is the part that's wrong. Okay, what's in the expression is what comes out of the expression. All right, now I can solve these two equations. So I would add 3 to both sides. So I get 2x is equal to 11. Divide both sides by 2, and you get x is equal to 11 halves. I'm going to add 3 to both sides, and I get 2x is equal to negative 5. Divide both sides by 2, and you get x is equal to negative 5 halves. So my solution set is x equals 11 halves and negative 5 halves. Okay, there's a couple of things that I can do with absolute value that's kind of a different setup for solving. All right, I want you to notice when I had this problem here that I had the absolute value is equal to a number. Okay, what happens if I have, let's say, 2x plus 1 plus 3 is equal to 8. Okay, see how the 3 is not inside that absolute value? So the rule is that you have to always get the absolute value by itself before you can solve the equation. So before I do any setting up of my equations, the first thing that I have to do is to subtract 3. So I get the absolute value of 2x plus 1 is equal to 5. Okay, then I can set up my two equations. 2x plus 1 equals 5. 2x plus 1 equals negative 5. Now I can solve. Subtract 1 from both sides, so I get 2x is equal to 4. Divide both sides by 2, and I get x is equal to 2. Subtract 1 from both sides, so I get 2x equals negative 6. Divide both sides by 2, and you get x is equal to negative 3. So my solution set is x equals 2, negative 3. All right, let's do another one of those just for good measure. So let's say I had the absolute value of x plus 9 minus 3 equals 7. So the first thing I have to do is get rid of the subtract 3. So I'm going to add 3 to both sides. So I get the absolute value of x plus 9 equals 10. So I'm going to set up two equations from here. X plus 9 equals 10. X plus 9 equals negative 10. So now I can subtract 9 from both sides and get x equals 1. Subtract 9 from both sides, so I get x equals negative 19. So my solution set is x equals 1 and negative 19. Okay, that's kind of one way to differentiate that problem from the original set of problems. The other way is to have two absolute values. So what happens if I have the absolute value of 3x plus 2 equals the absolute value of 5x minus 9? Okay, so the way we set this up is kind of the exact same way as we set it up if it were just a number. So here we set it equal to the positive of the number, and we set it equal to the negative of the number. So let's do that. We take the absolute value, and we set it equal to the positive of the number. Then we take the absolute value and set it equal to the negative of the number. Okay? So, if I have add that expression, it just comes out as the expression, 5x minus 9. But here, when I want to take the opposite of the expression, I have to make sure that negative gets distributed. So I have 3x plus 2 equals the opposite of 5, which is negative 5x, and the opposite of negative 9, which is positive 9. So that I can set up two equations. The first thing I'm going to do here is subtract 5x from both sides. So I get negative 2x plus 2 equals negative 9. Then I can subtract 2 from both sides and get negative 2x is equal to negative 11. Divide both sides by negative 2, and you get x is equal to positive 11 over 2. On this side, I'm going to add 5x to both sides. So I get 8x plus 2 is equal to 9. Then I'm going to subtract 2 from both sides. And I get 8x is equal to 7. Divide both sides by 8. And I get x is equal to 7 over 8. So my solution set is x equals 11 halves, 7 eighths. Now, let's do another one of those just so you have an example of another one. Alright, so let's say that I have the absolute value of x plus 7 is equal to the absolute value of 3x plus 4. Okay, again, I'm going to take what's under the absolute value and set it equal to the positive of the expression, and what's under the absolute value equal to the negative of the expression. So I would have on this side x plus 7. Positive of it is just what it is, 3x plus 4. And on this side I would have x plus 7. If I distribute that negative, the opposite of 3x is negative 3x. The opposite of positive 4 is negative 4. So on the left-hand side, I'm going to subtract 3x from both sides. So you get negative 2x plus 7 is equal to 4. I'm going to subtract 7 from both sides. So I get negative 2x is equal to negative 3. Divide both sides by negative 2, and you get x is equal to positive 3 halves. On this side, I'm going to add 3x to both sides. So I get 4x plus 7 is equal to negative 4. Subtract 7 from both sides. So I'm left with 4x equals negative 11. Divide both sides by 4. So I get x is equal to negative 11 over 4. So my solution set is 3 halves, negative 11 over 4. Now, there are two kind of questions that don't follow those rules. Alright? What if I have 2x minus 9 absolute value equals 0? So what that's saying is, tell me a number whose distance from 0 is 0 units. So if we look at the number line, there's only one number whose distance from 0 is 0 units, and that is the number 0. So instead of setting up 2 equations here, I only need to set up 1. So that I would have 2x minus 9 equals 0, and then I can solve that equation. Add 9 to both sides, so I get 2x is equal to 9. Divide both sides by 2, so you get x is equal to 9/2. Really, that makes it an easier problem if it's just equal to 0. The last one is, what if I had the absolute value of 3x minus 7 is equal to -4? Okay, so if we go back to our just previous definition of absolute value, it takes whatever's inside and makes it positive. So whatever is sitting here comes out as a positive number. So is a positive number ever equal to a negative number? No. So this problem has no solution. Okay, just another example so that you see it. If I have the absolute value of x plus 2 is equal to -8, what sits under the absolute value is always positive. So a positive number is never equal to a negative number. So my solution set is the no solution. So absolute values are really simple. In this section, there are 11 questions, and it has you go forward, and it does have you go backwards. And an example of that would be something like this. Tell me or write an equation for a number x whose distance from 0 is 8 or -8. Okay, and the way you do that is that you know if you've got 0 and I've got 8 as a distance, or -8 as a distance, that I have the absolute value of x is equal to 8. Really simple. Any questions on this, just email me and let me know. This concludes all of the videos, I think, for this test or for this section of homework. If I've missed something or you have questions or something, just shoot me an email and I'll send something right back to you. Thanks, guys. Have a great rest.